Guys, welcome to my tutorial. Today we're gonna do a quick problem. So the problem says a football player at the beginning of a game starts the game with a kickoff. He kicks the ball at a 45-degree angle at 15 meters per second. How far did the ball travel? So first of all, we need to do is draw this guy. So he kicked a football. So the path of the football will go something like this. And it comes down. So we know that, so what he says, he gave us is that the ball is at 45 degrees. So we could draw a triangle for it, for this situation. So it's at 45 degree. And it says that it travels at 15 meters per second. So what we have to do first is label what we have and what we know and what we need. So this is going to be d of x, v initial of x, v final of x, acceleration of x, and time of x. We don't need time of x because time of y and time of x would be the same, so we don't need to label that. So what we also need to label is the d of y, v initial of y, v final of y, acceleration of y, and t of y. So what we need to do now is we need to find the acceleration. We need to find we know the acceleration equals 0, and the acceleration of acceleration falling down is negative 9.8 meters per second square. So what we also know is that the displacement of y equals 0 for the reason because the ball starts here. When he kicks it off, it comes down at the same place it was. Not the same place, but at the same height it was. So displacement would be 0 for this case. So what we know also is that v initial of y, which is v initial of y, and v final, v initial, of x. So we're gonna use SOHCAHTOA to find this two. So, well, at this time I'm assuming you guys know some algebra, so I'm just gonna skip the steps of how setting up the equation for the sine and cosine. So I'm just gonna skip right to the end. So v initial of y would be sine of 45 times 15, and this would be cosine of 45 times 15. So with that being said, we could find the v final of y, and then we could find time. Then time would be the same for this too. So the equation I'm going to use to find v final is v final y squared equals v initial square plus 2ad. So all of these are labeled as y because they're for the y side, so you won't confuse them. So what we know is that displacement of y is 0. So we plug in 0, this cancels out this whole equation. So we just left with this two. So which means it's v final y square equals v initial. So v initial is what we said, sine of 45 times 15 squared. But since they're both squared, we could just cancel out the squares, and that means that sine of 45 to the 15 equals v final. So v initial and v final are the same. So this is going to be sine of 45 times 15. But this is going to be negative because at this time the v initial is starting off, so it's positive, and by the time it falls, this is negative because it's falling down. So it's negative sine of 15 times sine of 45 times 15. That being said, we could find t. We're going to use a different equation to find t. So to find time, we're going to use this equation. We're going to use this equation. T equals v final minus v initial divided by a, which is acceleration. So we need to find t. So we know that t equals, we know v final, so it's negative sine of 45 times 15 minus v initial, which is sine of 45 times 15, that's 15, divided by negative 9.8, because that's our acceleration, so it's meters per second squares, and these ones are both meters per second. So when you add these two together, I'm gonna punch in this in the calculator, and I'm gonna punch in this in the calculator also, which means they're negative 10.607 meters per second minus 10.607 meters per second divided by 9.8 meters per second squared. This negative also. So when we add them together, you get when you add them together, you get negative 21.213 divided by negative 9.8 meters per second squared. So when you divide them, this cancels out with this one, so you get left out with seconds. And negative divided by negative, it's positive, so it's 2.16 second. So that goes in here, 2.16 seconds. And since we said they're connected, this is also 2.16 seconds. With that being said, right here and right here, because they're the same. So now we have three pieces of things which we could find d of x. So now to find d of x, we're gonna use another formula now. So the formula we're gonna use to find d of x is d of x equals v initial of x times t plus 1/2 a and then times t squared. But recall, guys, that in this one, acceleration equals 0. So by plugging 0 in here, this will cancel out this whole equation. So what we end up having is v initial of x times t. So now we just plug in the numbers. So we're gonna have v initial, which is cosine of 45 times 15, and then which times 2.16 seconds. This is meters per second. So with that, we end up with the cosine of 45 times 15 is 10.607 meters per second times time, which is 2.16 seconds. So now when you multiply this together, the second cancels out the seconds. You're left with meters, and that's equals to 22.99763 meters, which is so that given that's 22.963 meters, which we could round up to get a more accurate distance, but we'll just leave it like that for right now. So the ball, when the football player kicked the ball, it traveled 22.693 meters.